Have you ever tried to buy concert tickets the very second they go live and poof, the entire site just vanishes? Well, that's not just bad luck. More often than not, it's a system design failure. Now, when we hear system design, our minds usually jump to those super intimidating whiteboard interviews, right? Or we think of all these complex diagrams and buzzwords like microservices or Kafka. But honestly, we're going to cut through all of that noise today.
Okay, so the very first thing we have to get straight is this. System design is not an art class. Seriously, it's not about who can draw the most complicated diagram with the most boxes and arrows. That's just what it looks like on the surface. The real work is so much deeper and, way more important.
Because at its heart, system design is really a discipline of making choices. And they're often tough choices, based on the very real limits you have to work with, like budget, time, and the actual team you have. It's all about deliberate, practical engineering, not just abstract drawing.
So, here's our plan for this explainer. We're going to go beyond the whiteboard to see what system design really is. We'll talk about the blueprint, not the building, to get the scope right. We'll look at why large systems fail to understand why this matters so much. Then we get to the good stuff, a framework for design. And we'll wrap it all up by talking about the engineer's real job in all of this.
All right, let's dive right in. It's time to move past all those interview stereotypes and really pin down what we're talking about when we say system design.
So yeah, here's the formal definition. It's basically the process of figuring out all the big pieces of the puzzle. You know, what they are, how they're going to talk to each other, and how they'll all work together to actually get something done. It's the master plan, the blueprint that guides how everything gets built.
And this right here is absolutely crucial. You don't finish the system design part of a project with a bunch of code. Nope. You finish with a set of well-thought-out decisions. Things like, okay, we're going to use a message queue right here to soak up traffic spikes, and we accept that it's going to add a few milliseconds of delay. Those decisions, that's the real product.
So now that we've got a handle on what it is, we need to be really clear about its scope. And honestly, the best way to do that is to see it next to something we're all a bit more familiar with: software design.
I love this analogy because it just clicks. Think of system design as being the city planner. You're the one deciding where the highways go, how the power grid is laid out, and where you're going to put the major zones. You're focused on that big, high-level infrastructure. Software design, then, is like being the architect for one single building in that city. You're focused on the inside, the classes, the functions, all the details that make that one part work perfectly.
So why do we pour so much energy into this blueprint phase? Well, because the stakes are incredibly high. Getting this part wrong doesn't just create a few bugs, it can literally bring down entire platforms and even businesses.
Just think about it for a second. A small app might break because of a simple typo in the code. But what about these massive, global systems serving millions and millions of people? The things that take them down are usually something else entirely.
See, large systems usually fail because of these big architectural choices made way at the beginning. Like maybe you relied on a single database that just couldn't handle the load and eventually cracked. Or you built everything so tightly connected that when one little piece fails, it starts a catastrophic domino effect. These aren't just coding mistakes, they're deep, fundamental flaws in the design. And system design exists to catch them before they can ever impact your users.
Okay, so if the stakes are that high, how in the world do we avoid these massive failures? Well, the answer isn't just hoping for the best. It's about having a structured, repeatable process that you can use for almost any problem you come across. And this framework gives us exactly that structure. So let's just walk through it real quick. 1, clarify the problem. 2, define your requirements. 3, and this is a big one, start simple. 4, identify your bottlenecks and where things could fail. 5, apply known patterns to those problems. 6, make your trade-offs explicit, super important. And finally, 7, adapt to the constraints of the real world. It's a roadmap to get you from a fuzzy idea to a solid plan.
Let's just zoom in on step 2 for a second, because this is where so many systems get into trouble. Functional requirements are about what the system does. Users need to be able to upload a photo. But non-functional requirements are all about how well it does it. How fast is it? How many people can use it at once? I'm telling you, most of the huge production outages you hear about happen because these non-functional requirements were totally ignored during the design phase.
And another principle that is just so important, always start simple. There's this huge temptation to try and build for Google-level scale from day one. You have to resist that urge. Just start with one service, one database. You have to remember that complexity is a cost, and you should only pay that cost when you absolutely have to. Over-engineering is just a recipe for a whole lot of pain down the road.
So, this brings us to our final and maybe the most important section here. The framework we just looked at is a great tool, but the real skill, what makes a great engineer, is a certain way of thinking.
Let's be perfectly clear on this one. There is no single right way to build a system. It just doesn't exist. The architecture that's perfect for Netflix's video streaming would be a complete disaster for WhatsApp's real-time messaging. The correct architecture is always, and I mean always, based on the specific context of the problem you're trying to solve.
And this quote just nails the core skill. Look, you can't build a system that's infinitely scalable, instantly consistent, 100% available, and costs nothing. It's impossible. A great designer doesn't pretend that they can have it all. Instead, they choose what to sacrifice and they make that choice intentionally and out in the open for everyone to see and understand.
So here's the bottom line. More than any diagram, more than any specific piece of technology, the fundamental skill of system design is the ability to reason. It's about looking at a problem, really understanding the constraints you're working with, and then logically navigating all the trade-offs to land on a solution that actually works for this specific situation. That right there, that's the mindset that truly matters.
Thanks so much for watching. If this explainer helped clear some things up for you, a like is always appreciated. And make sure to subscribe to Engineering Systems for more deep dives into core concepts and real-world systems.